In the previous classes, we have covered the preliminary wastewater treatment. In the preliminary wastewater treatment, we have already discussed on screening, communities, then grid chambers, detritus tank, skimming tank. In the primary sedimentation, we have discussed in detail regarding sedimentation and coagulation sedimentation. Now, we have entered into the third part of the wastewater treatment, that is the attached growth system. In this, we are going to study in detail regarding trickling filter and activated sludge process. Now, we are in today's class, we are going to discuss regarding the trickling filter. Okay, it is one of the attached growth system where we are going to discuss regarding what is trickling filter, what is how the construction of trickling filter will be done. Okay, what are the different types of trickling filter, that is a conventional trickling filter and a high rate trickling filter that is going to have recirculation, what is recirculation and all that we are going to see. Then we are going to discuss regarding the merits and the demerit of a trickling filter, then operational problems of trickling filter, that is fly, odor and ponding nuisance, all these things we are going to see. Then design of a trickling filter, then performance of a trickling filter. All these things we are going to discuss in today's class, and we are going to discuss in detail regarding the high rate trickling filter probably in the tomorrow's class, because covering these aspects, it is a huge amount of data is there in all these things. So probably regarding high rate trickling filter, we are going to discuss in tomorrow's class along with the some of the problems. Now, this is nothing but your diagram of the trickling filter, where I have told you that it is one of the attached growth system process. Okay, why we are going to call this first of all an attached growth system, right? So here, as you are going to see, this is going to have the filter media, which is going to have some of the coarser material. From this, the waste water need to pass, and it needed to be get filtered from these filter media, which is going to have the coarser material, right? From here, if the wastewater is going to have any of the fine suspended particles in it, it is going to be get attached into these coarser material. That is the reason why we call this a trickling filter as an attached growth system, wherein you are suspended particles or any organic matter it is going to present, it is going to be get attached to this filter media. This filter media will be made up of coarser material, and the wastewater will be, it is going to be get filtered through this filter media. That is the reason why it is going to get it is going to be sprinkled over this filter media, and it is going to fall drop by drop, and that is the reason why we call it as the trickling filter. Regarding this, I will be explaining in detail. I have just told you why it is called as an attached growth system. Okay, now the filters is also going to be called as percolating filters or sprinkling filter. Why it is going to have the sprinkling effect? It consisting of the coarser filter media over which all the sewage which is going to be allowed, which is going to be sprinkled, or it is going to trickle down by means of these spray nozzle. That is the reason why we call it as an trickling filter. Okay, now the decomposition of an organic matter which is going to resultant in the putrefaction of the sewage is going to be brought by the population of microorganisms. Here it is going to be get blocked, and there the microorganism action is going to take place. The microorganisms and the bacteria which are naturally present in sewage, it is going to get attached to this filter media, and that is the reason why we call it as the attached growth system. And the organic matter from the sewage, it is going to be get absorbed by the filtering media in the outer portion of the film, right? In the outer portion of this particular film, it is going to form the slime layer. As the microorganisms grow and the thickness of the slime layer, right, wherever as your wastewater is going to fall on these particular filter media, and then the organic matter which are present in this, it is going to get attached into this particular your it is going to be get attached over this particular filter media, which is going to form a slime layer. As the microorganisms grow, the thickness of the slime layer increases, and it is going to have the diffused oxygen is consumed by the upper portion of this particular slime layer, the layer of the microorganisms which is going to be get attached on this particular your filter media. We call it as a slime layer. You need to remember, we call that particular layer of microorganisms, we call it as a slime layer, and it is going to create anaerobic condition near the surface of the organic matter, and the metabolism is therefore it can reach the microorganisms near the media phase. Okay, so this is how your the microorganisms will be getting attached over each other, and then slowly the anaerobic condition is going to be get followed, and as the some of the microorganisms and the some of the suspended particle are going to be get attached over here, the filtered water is going to be get collected downside. Okay, now we will see the construction part of the trickling filter. This is nothing but your your drawing of a trickling filter. In your main exam, they may ask draw a trickling filter with the neat sketch and explain its operation. They may ask in your examination, and normally it is going to be asked into a mere exam. Now trickling filter is going to be, normally it is going to be constructed above the ground. Okay, the trickling filter will be, normally it is going to constructed above the ground, and they may either having a rectangular or circular in shape, and rectangular filters are provided with the network of pipes having the fixed nozzle. Now this type of trickling filter is going to have the rotary distributor. Okay, now here we are going to have the rectangle the filters with having the fixed nozzle, right? These are nothing but the main distributor arm, which is going to have the small nozzles to it, right? Which is going to spray the wastewater sewage into the air, and it is going to fall over the filter media. This is nothing but the filter media, right? The circular tanks, right, with having the other end here, the wastewater is going to be get inflated from here, and then it is going to enter, and then these rotary distributor arm is going to rotate, and it is going to give the wastewater to the filter media in the sprinkler format. Okay, now these distributor rotate centrally with having the riser, right? It is going to have the riser, and it is going to rotate at a speed of around 2 rpm to half rpm. The advantage of having the two or more arms here, it is going to have the number of arms, right? The advantages of having two or more arms is not only to get the reaction sufficient to rotate the entire mechanism, but also it is to pass the fluctuating demands by taking the flows into two arms. Okay, now the distributing arms should remain 15 to 20 centimeter above the top surface of the filter media. This arm should be above 15 to 20 centimeter. Now there is an important difference action of the rotary distributor with the spray nozzle is, with the rotary distributor, the application of a sewage will be continuous. Due to this, the application of sewage will be continuous, whereas with the spray nozzles, the spray has to be dosed for around 3 to 5 minutes, and it has to be rested if for 5 to 10 minutes before the next we are going to have the operation. Okay, it may be going to have the spray nozzles, or it may be have the rotary distributor. Okay, in any of the case, having the dosing tanks, the siphon receiving from the sewage, and it is going to having the supply of the air at the regular interval. The dosing tank with having the distributor with having the smaller capacity with having has to be designed for a smaller capacity for around 1 to 3 minutes, whereas the higher capacity for filters with the spray nozzle. Okay, the rotors, it has to be designed with the dosing tank, it has to be designed for a smaller capacity, that is for 1 to 3 minutes, and with having the spray nozzle, it has to be designed for the 5 to 10 minutes. Okay, now the wastewater will come from this influent, and then it is going to have the rising action. Here the with the central shaft is there, and then it is going to have the rotating mechanism, and from here the wastewater is going to get flowed down, and then from the filter media it is going to get filtered, and then the wastewater is going to be collected. As here you are going to see the under drains are there, it is going to have the slope over here, and then the wastewater whatever, since the slope is there over here, the effluent channel it is going to be collected outside. The filtering media, as it is going to have the coarser the material, right? The size of these coarser material will be around 25 to 75 mm. The filtering media should be it is going to be thoroughly washed before placing in the positions. Okay, the filter media will be having the depth of around 2 to 3 meters. This depth will be of 2 to 3 meters, and the filter media should be placed in layers with the coarsest stone at the top, and coarsest stone at the bottom, and the finest at the top. The finest coarser material should be placed at the top, and the finest should be placed at the bottom. And at the bottom here it is going to have the honeycomb structure. These under drains, it is going to be the made up of a honeycomb structure, so that whatever the water that is going to be flowed down, it should be easily flowed down, and it should be easily collected through these effluent, and it is going to have the slope of around 0.5 to 5% towards the effluent drainage channel, from where the wastewater is going to be taken out. Okay, and this is regarding how your wastewater is going to work. The wastewater will go from the influent, from the siphonic action it will go upwards, and it is going to be sprayed to the spray nozzle. It is going to rotate at a rate of around half rpm to 2 rpm. Then the wastewater is going to be get filtered over here. It is going to form a slime, and then the wastewater is going to be get filtered downside from these under drains. It is going to be collected here, and then the wastewater will be moved down. Now this is how your conventional trickling filter will work. Now coming to this particular diagram, they may be asked in your main exam, so this you need to draw it neatly, and you need to represent in your main exam. Now we will be discussing regarding what are the different types of trickling filter. The trickling filter will be of two types. We have seen just now we have seen the construction of the trickling filter. Now we will see what is conventional trickling filter and what is high rate trickling filter. Just you have seen the conventional trickling filter, the working of the conventional trickling filter you have seen. In the high rate trickling filter, as the name is indicating, high rate trickling filter, it is what the rate high rate filters of modern this thing, what they are going to have the same constructional details as your normal trickling filter is going to have, but only the difference between these conventional trickling filter and the high rate trickling filter, the difference is that the recirculation is going to be provided in case of your high rate trickling filter by pumping a part of a filter effluent to the primary settling tank. It is going to have the recirculation. In the your high rate trickling filter, we are going to have the recirculation of the waste water by the pumping media and to the primary settling tank, and repassing through it and the filter. The high rate trickling filter, it is going to require a lesser space, lesser filter media, and the process of recirculation and its use in the making high rate trickling filter shall be continuously and thoroughly it is going to be done. And in the your high rate trickling filter, we are going to discuss in later after having discussing these merits, demerits, and then operational problems that we are going to regarding high rate trickling filter, we are going to discuss in the next class. Okay, now we will see what are the merits and demerits of the trickling filter. The construction you know, and what is a trickling filter, conventional trickling filter and high rate trickling filter you came to know. Now we will discuss regarding the merits and demerits of trickling filter. Okay, now the merits of trickling filter is the rate of filtration loading is high, and it require lesser land and area for their installation. It requires very small land, and the smaller quantity of filter media is required for their installation. The effluent obtained from the trickling filter will be having the BOD removal capacity, right? The BOD removal capacity will be of around 75%, and it is going to have the suspended solids removal capacity will be having around 80% of the suspended particles can be get removed from these trickling filters. Okay, now the working of a trickling filter is very simple, and then it does not require any skilled supervision. It is going to have the flexible operation, and they are going to have the self cleansing effect, and then the moisture content of a sludge obtained from trickling filter is going to be high as 99%. Okay, the trickling filter have been found to operate with the more warm weather. Wherever the warm weather is there we can operate it, and it is going to have the good BOD removal and suspended solid removal capacity. It is going to have. We use these trickling filter in the countries like India, right? And then the disadvantage is the cost of construction of a filter is high, and these filters cannot treat raw sewage, and primary sedimentation is a must. Primary sedimentation is a must before we should before sedimentation we cannot go for your primary we cannot go for trickling filter. Okay, then these are the some of the disadvantages, and then it is going to have some of the operational problems. We will be discussing regarding these operational problems. It may be asked in your main exam, write a short note on the operational problems on trickling filter. It may be asked in your main exam. Okay, now we will discuss fly nuisance, as it is going to have the microbes in it, and as it is going to have the suspended solids, there will be the problem of flies which is going to be there. Okay, the fly or a cycoda, right, which develops in filter particles may prove to be nuisance, and it is going to have the fly nuisance, and this problem may be controlled by flooding the filter with the sewage for 24 hours. Then the flooding will destroy the larva and usually interface with the slightly results of operation. And another method of controlling these flies is to have the DDT, chloridins, then benzidine, hexachloride. By applying all these to the filter plant, we can avoid these the problems of fly nuisance. Then odor nuisance, as there is an decomposition of decomposition of microbes, or decomposition of organic matter is going to happen, the odor nuisance will be there. Right now, the odor nuisance will be providing by having it is going to have the odor of H2S gas. Right, usual this remedy is to chlorinate. Right, we can chlorinate, and these your trickling filter, and we can prevent the formation of H2S gas. Okay, then the ponding trouble, as sometimes the voids is going to be get blocked by the different kinds of suspended solids. There will be the ponding nuisance will be there, and there will be the growth of heavy fungi and algae will also be there in this your trickling filter. So that problem will also be there in case of the trickling filter. Now we'll discuss regarding the design of the trickling filter. Right, the hydraulic loading rate, right, the quantity of sewage that can be applied for conventional trickling filter. Right, conventional trickling filter, the wastewater quantity that may be applied is going to vary in between 222 to 44 million liters per hectare per day. Right, we can apply 22 to 24 million liter hectares per day, whereas your high rate trickling filter, we are going to apply the water of around 110 to 330 million liters per hectare per day. And the BOD loading rate that we can apply for conventional trickling filter is around 900 to 2200 kg of BOD per hectare meter can be applied, whereas for your high rate trickling filter we can apply the BOD loading rate up to 6000 to 18000 kg of BOD can be applied. Okay, then we are going to have in case of your rectangular trickling filter, the length will be around 60 meter, and in case of circular filter tank, the diameter should be around 60 meter, and if the filter media is more than 60 meter, then it is better to use the units of lesser dia, and the design of a rotary distributor and under drainage system should be done. Now regarding the performance, as I have told, it is going to have around your 75 to 80% of the BOD removal capacity will be there, and around it is going to remove the suspended solids up to about 80% of the suspended solids can be get removed. Okay, so this is regarding the brief introduction regarding the trickling filter. In the next class, we will discuss regarding the high rate trickling filter and the difference between the conventional trickling filter and high rate trickling filter, and then we will see solve one or two problems in the next class. So we have discussed what is trickling filter, what is construction of a trickling filter, how it can be done, and construction and operation we have discussed types. Then we have discussed merits and demerits, operational problems, design of trickling filter. All these things we have discussed in today's class. In tomorrow's class, we are going to solve problems, and we are going to see what is high rate trickling filter. Okay, thank you.